It used to be fun to create things, right? What about today in the energy industry? What's it like to create today? Complex systems and processes abound, and the flood of data can make life difficult and confusing. Combining these systems and data streams effectively over the long term is often a major challenge. That's where Xenon comes in. The Xenon software platform makes it incredibly easy to run production and infrastructure systems. How exactly does Xenon work? With Xenon, you can capture all of your equipment data in detail and analyze it in real time. Xenon manages and maps systems and processes, helps you to compare data at a glance, and gives you full access to critical information about your equipment. Additionally, Xenon enables you to implement digitalization projects quickly, easily, and accurately. How is the software platform structured? Xenon provides you with a strong foundation of complementary features. The software is fully scalable and provides the optimal combination of security and flexibility. You can build your various applications flexibly on this software platform. Fully automate substations, manage energy distribution, and monitor renewable energy generation. So get started today and achieve your long-term operating goals with ease. Xenon, industrial software that makes your life easier.
Hello and welcome to our webinar today about digital substation automation, in which we want to reflect the status of the energy industry. We want to discuss substation evolution up to the point of digital substation principles, and we want to discuss and investigate the role of HMI and the benefits of HMI in digital substations. Furthermore, we will see some practical examples and use cases how HMI can be used in digital substations. My name is Stefan Hufnagel. I'm from the energy team of COPA-DATA, and later we will be joined by Jürgen Resch, our long-time energy expert and industry expert, especially also in the domain of substation automation, and he's also director of the industry management here at COPA-DATA. A little bit of housekeeping. We have planned this session for around about 35 minutes of presentation time, followed by 10 minutes Q&A. So whenever you have questions, please submit them also during the presentations already via your Q&A input field. The session will be recorded, and you will get, after the session, after the webinar has been finished, you will get an email with all the information, a link to the recording, and also presentation materials and further information from this webinar or related to this webinar. So now to get started, to warm up, let me review a little bit the state of play of the industry with some impressions which we get from the industry as an independent vendor of automation and energy automation software. So first of all, obviously, there's a lot of renewable integration going on. So we see more and more large-scale SCADA solutions, projects. We see large-scale wind farms, onshore wind farms, and also offshore wind farms. So that means that the grid is confronted with a lot of volatile energy, with a lot of volatile power flow, and at the same time, a lot of new assets, like also substations, switch yards, need to be built, and also as we can see in the image, offshore platforms, for instance. At the same time, the energy demand grows as industries are switching processes from which were formerly fossil fueled to electrical or electrically powered processes. So we see a rise of electrification in the industry and also a growing number of microgrid projects, for example. All in all, this means that the grids need to be modernized and partially expanded. So we talk about old and legacy equipment, old substations, for example, which need to be modernized and refurbished. New assets need to be built, new substations or power lines need to be built. And at the same time, there there's a need for solutions in order to manage all these, or this growing number of assets in like central applications like SCADA and control center applications. And last but not least, of course, this leads to an increasing project workflow or project workload for energy companies. So we quite often hear the statement like, last year we did 5 substations, this year we have to do 8 substations, and next year we will have to do 15 substations. So these companies look desperately for possibilities to streamline, automate, and standardize their engineering processes. Now, what is the role of COPA-DATA in that industry? We are an independent software provider with a long time experience in automation, in energy automation, and also in other automation environments. And we now link also these possibilities with new mechanisms, new technologies, and possibilities for digital transformation. COPA-DATA has been founded almost 40 years ago and is still today a 100% family-owned business. Today we have well over 400 colleagues and employees worldwide, and our main product or our core product is the Xenon software platform, which is a generic energy automation and also and general automation platform. We have our customers are actually coming from all sides of the industry and across the globe. So we talk about transmission service companies, we talk about distribution companies, also large energy consumers, large industrial companies, and also railway companies, for example, for traction power. And on the other hand side, also system integrators or equipment builders in the energy industry. Now, focusing on the specific field of substation automation, the Xenon software platform can represent a rich set of solutions. For instance, substation HMI, so station level HMI, or substation gateway solutions, so connecting substations with central, national or regional control rooms, for instance. Substation SCADA systems or substation SCADA solutions for fleet management can be built based on Xenon. And the IEC 61850 digital substation standard is a standard which we are working on for many, many years already, helping customers to gradually and systematically switch over or transfer to these technologies for new and existing substations. And last but not least, the simplification and the automation of engineering. So speeding up development processes and workflows by using existing data out of design and implementation processing, using them in the engineering process and automatically generating projects, for example, a substation HMI configuration, automatically from that data. Now, to approach a little bit more the topic now of this webinar and of the subsequent expert discussion, when we talk about the transition from conventional hardwired substation and mostly analog technology and signal-based substations to digital substations, which are based on digital communication networks and mostly based on software, a lot of processes are impacted, a lot of processes within the development process of substation automation. For example, the planning and the specification, the procurement is impacted in the way how you can select the different devices from different vendors. The design and development process, of course, is also regulated or defined and specified in the 61850 standard. And also the testing commissioning. So on site then, when the substation is really built, the testing and the commissioning, the operation of the substation, of course, and also the refurbishment. So when equipment fails, for example, if you have to exchange it, also IEC 61850 provides standard ways and standard interfaces how to do that. And this is actually now the point to hand over to my colleague to give you or provide you with some more insights and practical examples how 61850 helps or works in these phases and how specifically Xenon brings benefits into the process of digital substation automation. So Jürgen, I'm passing the ball over to you. The stream is yours.
Here is the stream. Very good. Thank you very much, Stefan, for the introduction, and thank you for introduce the entire audience into this topic. And yeah, a warm welcome also from my side here from my office. And what are we going to talk about today? So the idea is to give you more insights about digital substations with a specific weight on the HMIs. So this is what we have prepared for you. First, I would like to elaborate a little bit on the topic of digital in the digital substation term. So what makes it actually digital? What says the market about it? And then we are going to dive quite deep into the 61850 world of the terms like mode, behavior, simulation. And this young lady declares here a nerd warning about what we are doing in that aspect then later on during the short presentation from my side. And at the end, we will conclude. We will talk a little bit about trends and give an outlook of our thoughts, how we see the future of digital substations and the energy transition. Okay, so there is already a quite huge installed base of IEC 61850 type substations, and more substations that have previously been built with other technologies like IEC 104 or DMP3, they are now turned into IEC 61850. So this is actually our perception or how we reflect the truth. Maybe the truth is somewhere different, but this is how it feels for ourselves. On the question, what is actually a digital substation? There are the ones, me or myself included, that are saying that IEC 101 or IEEE 1850 DMP3 serial, which were done already in the 1990s, are already digital substations. And then there are the others who say, no, actually a digital substation is a substation with a so-called 61850 process bus. So they claim both it's digital, but what have we learned recently? There was earlier this year in Leipzig the so-called Schutz- und Leittechnik-Tagung or tutorial, where this topic also was discussed. So we see the station bus, typically classic cabling to the process with a large control room, let's say, or large space for all the packs, so the protection, automation, and control equipment, and the process bus. And on the bottom right side. And the definition they had on this conference in Leipzig in spring of this year is, and I translated this German saying or this German sentence into English. A digital substation is when a process network exists that makes digitized data, such as sampled values and GOOS, available to other functions and other participants for further processing in real time and or vice versa. So that means, yeah, when you digitize the data very early, then you talk about a digital substation. And I would say this is clearly then the race for the other ones that say, okay, with the process bus, we talk about the digital substation. But I tell you what, we have now talked about that several minutes about the process bus, but from the perspective of a station HMI or a gateway, it is not so important, I would say. Because from the HMI's perspective, what really counts is the data that comes from the station bus, because the HMI is directly connected to its first network. It is like this in this picture. So the person is the HMI, and the person looks towards the horizon and thinks he sees the bay controllers, protection relays, and so on, but also the merging units. But that's not really true. What he sees is just actually the HMIs, and he's connected with them, and all data he thinks to see is actually indirect information from the process bus, indirect information provided by the so-called logical nodes LGOS or LSVS. And this is the level we are talking now. So if you don't know about the LGOS and the LSVS, we will talk about that in more detail later on, what it means. And if you run a digital substation, there are other things that will come up. For example, how to test a newly installed spare part. And this leads us to our first use case that we want to dig into a little bit deeper. So let's say we have this simple structure of our network, and let's say that a BCU, a bay control unit, fails like this. And we need to bring in a new one, and we exchange it with a spare part. Now the gray one is our spare BCU, and we have copied and loaded the configuration from the old one because we have stored it somewhere. No more details about that. As an HMI engineer, I now need to test if the control commands from the HMI would go down to the IED. I see all the measured values and the status information. I can see that, but in the other direction, I cannot see if my control command would even change the position of that switchgear. But as we are in a live system, and let's assume that we are not allowed to change the position of this switchgear for whatever reason. So how we do that? So it's actually like this. We want to send a control command to our new bay control unit, but it shall stop here, and it should not execute the opening command, for instance, for this switchgear. So the command should actually block at the physical output or stop at the physical output. And therefore, we have these famous blocked and test blocked behaviors of 61850 equipment. But let me explain that, what this means. Or before that, we go to the classic way. So how would we, in a classic way, test a bay control unit? We would have these terminals which are directly connected with the switchgear. And normally, if we would send a control command, it would go directly to the switchgear and operate it. But in our case, as we are not allowed to operate it, we would open the terminal, and then we would send the control command, and maybe we measure it or send these signals to a test device in order to get an indication, okay, the protection or the bay controller would have executed correctly. So that means for us in 61850 that we need to do that in a similar way. But we have here different behaviors, actually 5 different behaviors. And I do now a quick rush through these 5 different behaviors, and I do not tell you all the details, like, I don't know, how the quality is indicated with it. I'm only showing you to give you an overview about how these behaviors work and what's their result. So the first behavior is actually the same that we had before. So the behavior of this logical node is in on mode, and we just send a control command through that XCDR or CSWI logical node, and it would operate the switchgear. The test attribute of the Opera object is here in false or not in use. The next behavior is the blocked one that we saw before. So with blocked, this means that the command would not be executed, but all the things before that would be done. Still, the upper test attribute is in false. Then we have where a way or a behavior which is called test, where we have the test attribute set to true and the control command also to true. This means that only with this test to true and the device is in test, or the circuit breaker logical node is in test behavior, would then let through a test command, but this would directly operate the switchgear, but only if the upper test is set to true. And then we have the fourth one, my favorite. So this is a combination of test and blocked. So we would block the operation, but we need a test flag set so that this command goes until the end of this logical node. And then there is the last one, which is the off attribute, which means the test attribute is not considered. We do not care about it. We will not operate the control command, but still all services of this logical node need to be intact and provide, for instance, quality information. Knowing that brings us, or you should ask yourself now, how do you bring a logical node into this behavior, and how do you tell the HMI to send such a command with this attribute test to true? So first question I tried to answer here. So let's say the IED with the logical node, whatever type, shall be set to test blocked, or has now the behavior, it is in test blocked, and this behavior, so BEH object is in a read-only object. So somebody needs to set it. So it's the same way as you would have it with the switchgear. You have a control with the control value, and you read back the status value. The similar way it works here. So that means we need to write on the so-called mode object with the value we want to have. So this one is controllable. That means the mode, through the mode, we set the behavior of this logical node. To make things even more complicated, we have a relation between the logical device and the logical node. A rough idea about how this relation works is that these different behaviors and modes, they can have a value. You see it here, 1, 2, 3, 4, 5. And the higher the value, or the highest value of this combination wins, except for two cases when we have the logical node set to blocked and logical device set to test. They have a test blocked situation. The same is if we have it upside down for the device and the logic node. But this is nerdy stuff, very not complicated, but very deep. So I would suggest we go now into a live demo where we see how this works in detail and how the HMI can see these different behaviors. So what we will see is something like this. We have prepared one incomer bay for setting into the different behavior, and then we have also the information about the test flag. Okay, so I switch now over to the demo project. And the demo project shows here 3 incomers. 2 of them are already switched off, and only the 1 incomer we need to test now, or the device we need to test for responsible for this incomer, is now responsible for the entire substation here. So as this is a demo project, it is not a real substation connected. We can give it a try and switch that off. So I open, as an operator, I open now this circuit breaker, and yeah, we will see what happens. Everything is white now, so the entire substation is unpowered. We go back here and we click that on again. So we have that condition that we want to have. So now we are in that starting point where we are engineers and we want to test the new spare part. And how do we do that? So as a first step, we need to log in as an engineer. And to show you how that there is a difference in the view. So we see here this detail view of this incomer. We log in as an engineer, and now, as we are an engineer, you see that indicated here, current user, engineer, and we have this additional information for this incomer bay. And yes, now we set this device or this logical node into test blocked. So we get that information or indication here. So we have written to the behavior, we get back so we have written on mode, we get back the behavior. So this is how the behavior is now indicated. What this means now, if I would now send directly a command, and I open also this diagnosis event list here, if I would send now the open command or the open selection for this particular switch, we would get a reject from our command processing window, and we see also an error here because now the logical node is in the behavior test blocked, and it would not allow any normal commands without the test flag set. So how do we set the test flag? So my dear colleague who has prepared the entire demo project here has put that prominently here so that you see, okay, now we have set this logical node to test. You see it also indicated here in the event list. And if I would now send the control command, now I even can confirm that. So now the real command is sent down to the device, and you see clearly what happens or what not happens. What not happens is that the real circuit breaker is opened. So it remains closed. We see the data still coming in. There is still power flowing. What we see here is an indication, okay, you would have set it to open, and we got also a success from this operation OK attribute that indicates, okay, right before the open coil, we have catched the command, and we have not send it out. Okay, so let's set everything back. Now we can say, okay, our test is done. And we give away this one, and we set everything back on, and we log out as an engineer, log in as an operator, and now we can leave the substation and we can write our reports. That's the spare part device was tested successfully. This was use case number 1. Now we go back to PowerPoint and talk a little bit about how is it when we are entering a test device that is injecting goose messages for testing devices. And for that, we look into this construction again. So we have one IED, IED1, that is subscribed to two IEDs for goose messages, to one merging unit for sampled values. And when we want to isolate goose messages from a test device and we want to consider them, we need to set a device. In this case, it's the physical device, and that's also the reason why we talk about the LPHD logical node. We need to set it to simulation. This is done also again in this, control and status value thing. So we would send a command to the sim object of the physical device, and then we would receive the status value of the sim object, and we can use this for a visual indication that this bay or this device is now in simulation mode. As a next step, we can now before we introduce the test device, I need to tell you, and this is clearly shown here also in the PowerPoint, we can set a device into the simulation mode, but as long there are no simulated goose messages injected, the device keeps on subscribing to the goose messages it is used to be or it is configured for, and is also executing these goose messages. And now the test device comes into the game, and we connect this device to our network. And as soon as the test device starts to inject goose messages, for instance, the similar configuration or configured messages coming from the IED2, for instance, then the device starts to only accept the simulated goose messages, and it will ignore or block the other messages coming over the process bus, because now it is only subscribed to the goose messages. And for the HMI, how is this indicated? And now we talk about this logical node LGOS, which has an own SIM status object. And if this SIM status object provides us a true, we understand, okay, now this subscription is only running with simulated goose messages until we set it back. So we put away the SIM status of the device, or there is a timeout, a certain timeout. Maybe before we go into the live demo, where we will show this simulation part here, a little bit of an let's say reality check. So how would we do that in reality? In reality, we would not just set something into simulation and inject any some goose messages, simulated goose messages. We would also do a similar test that we have seen before, but now the commands are coming from, I don't know, a breaker failure protection, for instance, where when there is a breaker failure and our device needs to react on that via a goose message that is sent out, or several goose messages that are sent out, we want to test it. But also in this case, for instance, we want to keep the circuit breaker closed. Then we combine the two things, the simulation and also the behavior that we have seen before. Because for a logical node, it doesn't make any difference if the trigger comes via a goose message with the quality test, or if it comes from the MMS client-server protocol with the quality test. But this is just to give you an understanding what we would actually do in real life. But as said, with our demo, we are just concentrating on this simulation thing. And there also, again, my dear colleague Luis has implemented this nice overview screen. We have 3 different subscriptions for in the different IDs. We are subscribing to our neighbors. We see here the string of the subscription itself. We see the status of the combination of these two flags, let's say. So the status of the subscription for the real subscription or the status of the simulation. And then we have also an aggregated information about if there is any simulation going on in the substation, so that the control center gets this one important information. But we look at this now in more detail here in the demo. And again, I need to log in as an engineer. And when the engineer is accepted, we see here now this indication. Currently, nothing is going on, no simulation subscriptions. I click here, and here I get this beautiful screen. And yeah, as said, currently is everything going well. But we have already a test device connected. And so we put now one device into simulation. We see that indication here. We would also see that indication in our communication screen. So also this device now is in simulation mode. So this is indicated here clearly in a graphic way. And now I bring this back. So we see also that the aggregated alarm is there. So the control center knows, okay, there is something simulation work going on down there in the substation. And we see that we have a clear subscription of a goose message, but we know it is a simulated value here. So two green lights here is actually something that we need to look into it, take care about it. What we want to have actually, the standard position should be this one. And we look again, if we click on that, so we get a waiting for normal or simulated goose in this state model. And once we have received the goose message, we see, okay, we have got a simulated goose message here. So that's actually it. And when we go back, it again follows the state model, waiting for normal goose, because we have taken away the simulation. And once the normal goose from the other devices is received, we get the clear indication. And also now we are taking away the simulation status of the last one. There are no simulated gooses anymore coming in, and also therefore the sim status for our control center is now clear. So our job is done, or the presentation here in the demo is done. I go back, set this to operator. I go back to my presentation, and after this use case 2, I'm at the end of my session. I just want to conclude and give you a little bit of an outlook. So when we talk about digital substations and you're an HMI engineer, you can say it is a little bit more work. You have more data to consider, but it's not rocket science. So you can help for your engineers for testing, isolate goose and make this visible. So this is clearly possible with an HMI software like we have seen before. And clearly the trend goes towards these digital substations, because the entire world, the entire globe is going towards digitalization. And maybe it's currently a problem of generations, but the next generation will do that. This is a trend that we see, and this is a trend that we trust in, actually. And then there is two other things regarding the energy transition. So one thing is that we see not only standardization bodies, but also utilities that are heading towards a formalization, a standardization. Why? Because they want to build their substation faster. They want to, they want to pick up the pace so that the energy transition becomes reality. And therefore, actually, you need digital substations, because it is much, much easier to copy and paste a configuration in 6150, and it's much slower if you need to dig cable trenches. So you can easily copy and paste 6150, but you cannot copy and paste cable trenches. With that, I hand over back to Stefan. Thank you very much.
Okay, thank you, Jürgen. Thanks. That was very impressive from our point of view. So seeing these functionalities, these processes like virtual isolation, the simulation in practice, and it's always good to see things in motion and see how things work. So the interesting point that all of this is standardized in IEC 61850. So all of that would work equally regardless of the specific hardware which is being used. So now we switch over, as promised, to the Q&A session. We're quite well in time, I would say. And during your presentation, Jürgen, already some questions arrived. So please keep putting your questions into the Q&A prompt. Obviously, we'll not have the time to answer all of them here in the live session, but we will, after the webinar, take care of it and probably contact you back with the information with our answers to your questions. So, Jürgen, I saw a first interesting question is about the editions. Richard asks, how about the support of edition 1 and edition 2? So I guess that's probably about the support of these two versions of 61850 or devices in a configuration with Xenon. Can you comment on that?
Yeah, I'm not sure if I'm not in the if I'm in the stream right now.
Yes,
I am. Okay, great. Thank you very much. Okay, edition 1 and 2. Yes, this is actually easy to answer. We have when edition 1 or when 61850 came up, and later on it was edition 1, we certified our IEC 61850 client driver, and we developed the same driver then also for edition 2 and certified it. And this means that all that stuff that was integrated for edition 1 is still there. That means you can even mix your substations. If you have older equipment with edition 1 and equipment with edition 2, you can mix them up and operate and run them in parallel. So the Xenon IEC 61850 client driver supports both editions at the same time.
Mm-hmm. Okay, sounds good. Another question comes from Olivia, and sounds pretty general, at least. How do you handle security? So maybe I can answer on that one probably. So when we look, of course, about energy, application security is a very important topic. And when it comes to Xenon and the contribution of Xenon to the security level of an application, it's always a mixture and a combination of different methods, of different security methods and design methods in security. So we explained it always as a defense in depth architecture. So when we talk about the communication, or when we have a look at the communication, it's obviously about encryption and authentication. So Xenon here supports TLS encryption and authentication according to IEC 62351, for an instance. On the other hand side, it's about the observation of communication connections. So also Xenon offers possibilities to detect and see the communication behavior, for an instance. And another point is the patch management. So having a simple way to patch the systems to apply updates is another component. Or user authentication, of course. So Xenon supports central user management, for example, in combination with Active Directory or other directory services. And last but not least, an application can be set up, or security can be increased by setting up an application in a modular way. And Xenon is a multi-server, multi-client system, which makes it possible to split up an application into several instances with a clear and defined communication in between, which means you can always build things and architectures like DMZ. You can separate critical parts of the application from non-critical parts. You can and also you can apply firewalling or intrusion detection in combination with Xenon. So in our development, we are very aware or very much considering that Xenon always can be used in combination with all the professional techniques which exist out there, like intrusion detection or firewalling and things like that. So I hope that gives a rough answer to that question, how we can or how Xenon handles security. I have another question from Deepak. Have your solutions been used as a master SCADA system which integrates with multiple site SCADA systems to provide a centralized overview? Probably, Jürgen, you can respond to that one.
I can respond to them. Yes, yes, and also the other way around. So both sides are possible. But let's say if Xenon is the master SCADA system, it has the possibility to connect to the lower level HMI or SCADA systems through different means, like standard data communication, like DMP3 104, for instance, or 6150 if you need, or ICCP. And then there is another possibility. You can also, if the lower level SCADA system provides a web server, you can integrate the screens or this web server content into Xenon directly, because Xenon has its own HTML screen type where you can show the content of a web-based SCADA system. So this looks then very, very integrated and has the same, of course, the same look and feel for the ones that are used to work with the lower level SCADA system. So yes, this is possible. And if the lower level SCADA system is also Xenon, then it's even better, because then you can directly integrate that into a so-called multi-client, which is directly importing all the projects as it is, and you have no additional engineering efforts.
Mm-hmm. Okay. Thanks, Jürgen. Another question I'm picking now from the list, which is probably a little bit related. Can a digital substation work with a DMP3 control center connection? So I assume that the situation is like that. You have a legacy control center on top, which is DMP3. And now the question is, can you go for 61850 in the substation below? And how would Xenon support that?
Yeah, so Xenon would support that directly. If you're okay with a Xenon gateway, which is a piece of software running either directly on the HMI or in a parallel machine as a Xenon client, you can directly communicate with the control center through DMP3, and Xenon translates then this information into 61850, or vice versa. The 61850 status information from the field is then translated by Xenon into DMP3. So this is a standard procedure how utilities integrate Xenon through a so-called gateway. The same would be if you would use IEC 6870-104 instead of DMP3.
Mm-hmm. Okay. One question, I guess here it goes a little bit in more detail, is how do you support fast report configuration? So I assume that it's a quite tedious job if you have a lot of devices and probably all of them are configured. Probably we are talking about a bottom-up approach. And now how do you get the report configuration into Xenon?
This will be a long one. Shall we take that? Okay, anyway, so report configuration in 61850. So reports are the spontaneous communication, and we know unbuffered and buffered reports. And the configuration itself can either be done in the client directly, let's say a kind of manual You can type in how the report control block is called and that you want to subscribe to it. But this is of course quite it's not so handy. What you also can do is that you rely on an SCD file, so a system configuration description, which includes a client LN section. So that means that you define which client gets which reports. And you can say, okay, this one client is the HMI, and it gets these and that reports. They are reserved for them. And to even speed up this one, you might need an ICD file or CID file from Xenon, from the client itself. And if you are in that situation, we are happy to help you to provide you with the ICD file of Xenon.
Mm-hmm. Okay, perfect. Sounds good. And one last question. We are already a little bit in overtime. I don't want to exceed the webinar for too much. Is can you use? So we've seen some visualization. Can you use IEC symbols in your single line diagram with the same pop-up windows as you used as for the ANSI?
Thank you. The simple answer is yes. So we have a fully graphic system here in place. All the symbols that you have seen are drawn by an engineer, some engineer from COPA-DATA in this case. And if the symbol is IEC or ANSI or something else, some utility standard, it actually doesn't matter. If you want to use these predefined symbols that you have seen today, because you do not want to create your single line diagram from scratch, they are already integrated. It's just a matter of switching these types of symbols, and you can switch from ANSI to IEC or vice versa. So it's easy as that.
So very flexible in that sense. Okay, so that's it. Thank you very much for your attention. Thank you very much for following up. Thank you, Jürgen, for your expert insights, and see you soon, hopefully in the next webinar. Thank you very much.
Thanks. Bye-bye.